In June 1950, North Korean forces, backed by Soviet, supplied T-34 tanks, poured across the 38th parallel, overwhelming South Korean defenses that possessed no tanks of their own and no proven anti-tank weapons capable of stopping the advance, a collapse so rapid that Seoul fell within 3 days. 7 decades later, South Korea's defense industry had transformed so completely that its newest tank, the K2 Black Panther, was being marketed internationally as a genuine rival to Germany's Leopard 2 and America's Abrams, only for the program to nearly collapse just before full production over a single component. A domestically developed automatic transmission that kept failing durability testing, forcing engineers to quietly import German power packs for years, while a homegrown replacement remained stubbornly unfinished. This episode traces how South Korea built an advanced tank program from a standing start in a matter of decades, and why the one component nobody expected to cause trouble, the transmission, connecting a proven engine to a proven gearbox, very nearly kept the country's flagship tank out of its own army's hands. That single mechanical bottleneck, unglamorous compared to the tank's gun or armor, would end up dictating the program's entire production schedule and forcing an uncomfortable compromise that South Korean engineers had specifically designed the whole project to avoid. South Korea's post-war military rebuilding began from close to nothing, its army equipped through the 1950s and 1960s almost entirely with American surplus equipment, including M47 and later M48 Patton tanks, supplied under military assistance programs rather than anything designed or built domestically. That total dependence on foreign equipment reflected South Korea's broader economic condition in the decades immediately following the Korean War, when the country ranked among the poorest in the world and possessed essentially no heavy manufacturing base capable of producing a modern armored vehicle from scratch. South Korean officers training on those American surplus tanks through the 1960s often did so with equipment already a full generation behind what American forces themselves were fielding, since surplus transfers naturally lagged behind whatever the donating military considered its own current frontline standard. The turning point came gradually through the 1970s and 1980s, as South Korea's broader industrial economy underwent rapid transformation, with companies that began in shipbuilding and civilian heavy machinery increasingly diversifying into defense production, backed by a government determined to reduce reliance on American military assistance and develop indigenous defense manufacturing capability. That ambition first bore fruit with the K1 tank, developed through the 1980s with substantial American technical assistance, and entering service in 1987, South Korea's first indigenously assembled main battle tank, even though it relied heavily on adapted Western components rather than a fully domestic design. A South Korean defense engineer who worked on the K1 program recalled the steep learning curve involved. We were learning to build a tank and build a defense industry capable of building tanks at the same time, and neither task waited politely for the other to finish first. The K1's development proved that South Korea could assemble and partially manufacture a modern tank, but it also made clear just how much of the vehicle's most demanding components, particularly its transmission and fire control systems, still depended on licensed foreign technology rather than genuinely domestic engineering, a gap South Korean planners explicitly set out to close with whatever came next. That ambition collided with South Korea's specific strategic predicament, a heavily mountainous peninsula facing a numerically larger North Korean armored force just across a heavily fortified and permanently tense border, a geography and threat picture that demanded a tank combining serious firepower and protection with genuine mobility across difficult terrain rather than the wide-open tank country that had shaped much of NATO and Warsaw Pact doctrine during the Cold War. South Korean defense planners studied both American and German tank development closely during the 1990s and 2000s, drawing on the Abrams program's emphasis on crew survivability and the Leopard 2's balance of mobility and firepower, while insisting that the next-generation Korean tank incorporate a genuinely domestic automatic transmission rather than continuing to license the technology from abroad. A decision driven partly by cost and partly by a broader national strategic goal of achieving defense industrial self-sufficiency across every major weapons category. South Korean industrial policy through this period consistently prioritized reducing dependency on any single foreign supplier for critical defense components, a lesson partly drawn from the country's own experience of American arms sales occasionally being subject to political conditions or congressional approval delays that Korean planners preferred not to remain permanently exposed to for a weapon system as central as its main battle tank. That same policy extended beyond tanks to fighter aircraft, naval vessels, and missile systems, part of a broader multi-decade South Korean strategy of building an increasingly self-reliant domestic arms industry capable of supplying the nation's own military without depending on any single foreign government's continued political goodwill. That transmission requirement, seemingly a modest technical ambition compared to the tank's more headline-grabbing armor and gun specifications, would prove to be the single most consequential decision of the entire program, since South Korea's heavy industry, despite decades of accumulated expertise in shipbuilding, automotive manufacturing, and electronics, had never previously attempted to develop a transmission capable of handling the specific combination of extreme torque, rapid gear changes, and prolonged heat stress that a 50-ton tank operating in mountainous terrain demanded. The lineage behind the K2 begins with that K1 tank, which entered service in 1987 carrying a crew of 4, a license-produced 105mm M68 rifled gun derived from the American M60 Patton's armament, composite armor of undisclosed but moderate thickness on the turret and hull front, a German MTU diesel engine producing around 1,200 horsepower paired with a General Dynamics-derived automatic transmission, and a range near 500 kilometers with a top speed of 65 kilometers per hour. It solved South Korea's immediate need for a modern tank considerably more capable than the aging American Patton tanks it replaced. But its reliance on a foreign-designed transmission and a rifled rather than smoothbore main gun already left it a step behind the very latest NATO designs by the time it entered full production. A K1 crew commander who trained on the tank in its early service years recalled the pride mixed with awareness of its limitations. It was the first tank that felt like ours, even though everyone who worked on it knew large parts of what made it work still came from somewhere else. Crews training on the early K1 also described a distinctly Korean adaptation to the tank's operating environment. One driver recalling exercises in the country's steep, forested terrain, where you learned quickly that this was not a tank built for the flat plains you saw in American training films. Every slope and switchback taught you something the manuals hadn't quite covered. That awareness of a tank that was Korean in name and assembly, but not yet Korean in its most demanding underlying components, set the specific technical ambition for the next generation, a genuinely indigenous automatic transmission, alongside a smoothbore gun matching contemporary NATO standards, developed without the licensing dependencies that had shaped the K1. South Korean defense planners at the time reportedly viewed this ambition as a matter of national prestige as much as pure military necessity, wanting the country's flagship tank to stand as concrete proof that decades of rapid industrialization had produced not just a manufacturing economy, but a genuine engineering culture capable of solving problems no domestic company had ever previously attempted. The K1A1, an upgraded K1 variant introduced in the mid-1990s, replaced the original rifled 105mm gun with a license-produced 120mm smoothbore weapon closely related to the German Rheinmetall design used on the Leopard 2 and early Abrams variants, alongside improved composite armor and a modestly uprated version of the same German-derived engine and transmission combination. It carried the same four-man crew, the new 120mm smoothbore gun, backed by a coaxial machine gun, hull and turret armor improved over the original K1, though still not officially disclosed in detail, the same roughly 1,200 horsepower MTU diesel engine, and similar range and speed figures to its predecessor. It solved the firepower gap that had left the original K1 undergunned, compared to contemporary Western tanks, giving South Korean crews genuine parity in main gun performance for the first time, but the transmission and broader power pack remained entirely foreign-sourced, a persistent dependency South Korean defense planners were determined to finally eliminate with the next full generation of tank design, rather than simply upgrading around indefinitely. The switch to a smoothbore gun also required an entirely new ammunition production line domestically, since the older rifled 105mm rounds could not simply be adapted, giving South Korean industry its first real experience manufacturing modern armor-piercing fin-stabilized, discarding sabot ammunition from the ground up rather than under a narrower existing license arrangement. A K1A1 maintenance officer recalled the specific frustration of that continued dependency during the vehicle's service life. Every time a transmission needed major repair, we were waiting on parts and technical support from outside the country, which is not where a nation serious about defense self-sufficiency wants to still be standing after 2 generations of tanks. That same officer noted a related but distinct frustration around the improved 120mm guns ammunition supply, since South Korea still relied partly on licensed foreign production for certain specialized round types in the years immediately following the K1A1's introduction, meaning even the tank's headline firepower upgrade carried a lingering dependency alongside the more obvious transmission and engine issue. That frustration directly shaped the K2 Black Panther program, formally launched in the mid-1990s, with full development proceeding through the 2000s and initial limited production beginning around 2014. The K2 carries a crew of 3, its 120mm smoothbore gun, domestically developed, though closely related in caliber and general performance to contemporary NATO 120mm weapons, backed by a coaxial machine gun and an autoloader, eliminating the traditional 4th crew position entirely, a significant departure from both the K1 lineage and most Western tank designs, which had generally retained human loaders. A gunner who trained on early K2 prototypes described the adjustment to fighting without a human loader beside him. You missed having another set of eyes and hands in the turret at first, but the autoloader never got tired after the 50th round the way a human loader eventually would on a long exercise. Crew training for the reduced 3-man arrangement also required rethinking maintenance procedures that had traditionally relied on a 4th crew member's labor for routine field tasks, a logistical adjustment South Korean training doctrine incorporated gradually as the K2 fleet expanded through the 2010s. Armor combines domestically developed composite layering across the hull and turret front with an add-on modular protection package. Figures South Korea has kept largely classified, though independent analysts estimate protection broadly comparable to contemporary Leopard 2 and Abrams variants, against both kinetic and shaped charge threats. The intended engine was a domestically developed Doosan diesel producing approximately 1,500 horsepower, paired with the equally domestic S&T Dynamics automatic transmission that had been the program's central self-sufficiency goal from its inception, together intended to give the roughly 55-ton tank a range near 450 kilometers and a top speed of about 70 kilometers per hour, figures that, if achieved as designed, would have made the K2 among the most mobile main battle tanks in its weight class anywhere in the world. Beyond raw mobility figures, the K2 was also designed with an active suspension system, allowing the driver to adjust ride height and even tilt the hull to increase gun depression and elevation on slope terrain, a feature specifically developed with South Korea's mountainous operating environment in mind, and one that had no direct equivalent on either the Abrams or the Leopard 2 at the time of the K2's design. It was that transmission, rather than the gun, armor, or engine, that became the program's defining crisis. During extensive durability testing through the early 2010s, the domestic transmission repeatedly failed to meet the required service life standard, breaking down well before covering the distance South Korean military specifications demanded before a major overhaul should be necessary. A South Korean Defense Ministry procurement official, who oversaw part of that testing period, described the repeated disappointment bluntly. Each time we thought the engineers had solved it, the transmission would fail again in the next round of trials, sometimes at a slightly longer distance than the last failure, which was progress, but not nearly enough progress. Testing protocols required the transmission to withstand many thousands of kilometers of simulated operational use, including repeated steep-grade climbs and rapid forward-to-reverse direction changes meant to replicate combat maneuvering, benchmarks the domestic design fell short of by a significant margin during its earliest testing rounds, despite passing basic bench testing under more controlled, less demanding laboratory conditions. The problem proved specifically rooted in the transmission's internal components struggling to handle the sustained heat and mechanical stress generated when paired with the powerful domestic engine across the demanding combination of steep gradients and rapid direction changes South Korean mountainous terrain and doctrine both required, a combination of stresses considerably more severe than the transmission's design had originally accounted for. Rather than delay the entire program indefinitely while the domestic transmission problem was solved, South Korean defense planners made the pragmatic, if institutionally embarrassing, decision to field initial production batches of the K2 with an imported German power pack, pairing a German MTU engine with a German Renk transmission, essentially the same combination used in contemporary Leopard 2 variants, allowing the tank to enter South Korean Army service on schedule while domestic transmission development continued in parallel. That decision required careful political handling within South Korea's own defense establishment, since the entire program had been publicly framed for years as proof of the country's growing defense industrial independence. Making the choice to import a core German component, even temporarily, a source of genuine institutional discomfort for officials who had championed the self-sufficiency narrative to legislators and the public alike. A program engineer who worked through that transition recalled the frustration of the compromise. We had built a tank meant to prove Korean self-sufficiency, and here we were putting a German transmission in it, which nobody who had worked on the program for years found easy to accept. South Korean domestic engineers continued refining the S&T Dynamics transmission across the following decade, and later production batches beginning around 2019 finally incorporated an improved domestic transmission design that met the required durability standards, though the German power pack batches remained in frontline service alongside the domestically equipped vehicles, creating a fleet with two meaningfully different mechanical configurations depending on production year. Maintenance crews servicing the mixed fleet had to maintain proficiency with both power pack configurations simultaneously, a logistical complication South Korean Army depots managed through separate parts inventories and specialized training tracks depending on which specific transmission a given unit's vehicles carried. An administrative burden that program planners had never anticipated when the transmission requirement was first written into the K2's original specifications decades earlier. Export customers evaluating the K2, including Poland, which signed a major procurement agreement in 2022 amid heightened regional security concerns following Russia's invasion of Ukraine, generally received versions equipped with whichever transmission configuration best matched their specific delivery timeline and logistics preferences. a flexibility that turned what had begun as a domestic engineering embarrassment into an unexpected practical advantage in international sales negotiations. Poland's decision, driven by an urgent need to rapidly modernize its own armored forces, given the war unfolding just across its border, prioritized speed of delivery above all else, making South Korea's demonstrated ability to produce K2 tanks quickly, regardless of which power pack configuration was installed, a genuinely attractive selling point, rather than the liability it had originally represented within South Korea's own domestic self-sufficiency narrative. Polish officials involved in the negotiations reportedly valued South Korea's willingness to begin deliveries within months rather than the years typical of comparable Western tank procurement programs, a responsiveness that owed something, if indirectly, to the manufacturing flexibility South Korean industry had been forced to develop while managing two parallel power pack supply chains during the domestic transmission's extended development period. Assessed on its own terms, the K2 Black Panther represents a genuinely capable modern main battle tank, combining firepower and protection broadly comparable to the best Western designs, with mobility specifically tailored to South Korea's demanding mountainous terrain, achieved by a defense industry that began the post-war era with no domestic tank manufacturing capability whatsoever. Its persistent difficulty developing a fully reliable domestic transmission, a problem that took the better part of a decade longer to resolve than program planners originally intended, illustrates how even a well-funded, technically sophisticated defense program can stumble badly on a single component that appears, on paper, less glamorous than the gun or armor that typically dominates public attention. That specific vulnerability, a nation with genuine expertise in automotive and shipbuilding manufacturing, still finding a tank-grade automatic transmission unexpectedly difficult, offers a broader lesson for other emerging defense industries pursuing similar self-sufficiency ambitions. The components that attract the least public attention during a weapons program's development are sometimes exactly the ones capable of derailing the entire schedule. The K2 program's eventual success in fielding both German power pack and fully domestic variants side by side, rather than either abandoning the domestic transmission goal or delaying the entire tank indefinitely, reflects a pragmatic engineering culture willing to accept an imperfect interim solution rather than let a single stubborn component derail an otherwise mature and capable design. That willingness to compromise on sequencing, fielding the tank on schedule with an imported part, while continuing parallel domestic development, rather than insisting on all-or-nothing self-sufficiency from day one, may ultimately prove as important to the program's long-term success and export competitiveness as any single specification of the finished tank itself.